Alright, so we have the solution to the test, the tutorial problems on industrial instrumentation. We have the solution to the 4 problems earlier posted on the channel. And here we have the solution on the screen. As you can see, the first problem states that state 2 advantages of using a thermocouple for temperature measurement. We have 3 advantages listed here. Thermocouples are cheaper than resistance thermometers. Thermocouple follow the temperature changes with a small time lag and as such are suitable for recording comparatively rapid changes in temperature. Also, thermocouple are very convenient for measuring the temperature at one particular point in a piece of apparatus. So we have 2 points there. And we also go to number 2. Write short notes on the following flow measurement devices: venturi tube and a flow nozzle. A venturi tube is constructed of a circular, square or rectangular section of gunmetal, stainless steel or cast iron, and its basic form is a special shaped length of pipe resembling the furnace joined in their small opening as shown here. 2 furnaces joined together at the small opening. The venturi tube is used for large pipe sections and is much more accurate than nullifies plates, but considerably more expensive and more difficult to install. The pressure recovery of the device is excellent, which means that there is little pressure drop through it. Okay, so we have the figure here. The device does not obstruct abrasive sediments and it resists wear effectively. So we have the structure of the device. Now, to measure pressure with flow nozzles, flow nozzle is constructed of similar material, but it's like entering half of the venturi tube, and it's a primary flow rate sensing element, which the pressure difference created during the flow. The device combines the simplicity of the orifice plates with the low losses of the venturi tube and is preferred in many applications. Though it is simpler and cheaper than the venturi tube, it is slightly less accurate and does not provide as good pressure recovery. We have the sketch, the section of the flow nozzle also. So those 2 problems earn you 5 points. Then we have number 3. It's a question on thermocouple that produces 12 millivolts according to the temperature difference between the sensor tip and the gauge edge. Sensor tip is θ1, gauge edge is θ2, so that it follows the equation E equals alpha to bracket θ1 minus θ2 plus beta bracket θ1 square minus θ2 square. Alpha is given as 3.5 times 10 raised to 5 and 10 raised to minus 5, and beta is 8.2 times 10 raised to minus 6. The gauge edge is 20 degrees C, and then you have to calculate the temperature at the sensor, 5 points. So we have the equation written down here. So if you just go around this equation, first thing is to express the equation to form the quadratic equation. So when you open up the brackets, then you collect the like terms and rearrange. So as you do that, you will realize something like E equals alpha θ1 minus alpha θ2 plus beta θ1 minus beta θ2. So beta θ1 plus alpha θ1 minus alpha θ2 minus beta θ2 minus E is equal to 0. Alright. Now, if you divide through by beta, we have θ1 square plus alpha over beta θ1 minus alpha over beta θ2 minus θ2 square minus E over beta is equal to 0. So now we can substitute the values of alpha and beta and the EMF produced, which is 12 millivolts. So if you do that, you have the next line, theta 1 squared plus 3.5 times 10 to the minus 5 divided by 8.2 times 10 to the minus 6, theta 1. Plus 3.5 times 10 to the minus 5 divided by 8.2 times 10 to the minus 6 times 20 minus 20 squared minus 12 times 10 to the minus 3 divided by 8.2 times 10 to the minus 6 equals to 0. So if you simplify, we have theta 1 squared plus 4.27 theta 1 minus 85.37 minus 400 minus 1463.4 is equal to 0. Theta 1 squared plus 4.27 theta 1 minus 1948.77 is equal to 0. So you use quadratic expression to solve this. We have theta 1 equals plus is equal to minus b plus or minus square root of b squared minus 4ac. In this case, minus b is equal to 4.27 minus 1.27 there, plus or minus square root of b squared, 4.27 square minus 4ac, so it will become plus 4 times 1948.77 divided by 2. Thus, the positive answer will be theta 1 equals 42.06 degrees C. I will neglect the negative answer. That's 5 points. And the last problem, it is required to determine the pressure difference between 2 points A and B in a hydraulic system, and the differential pressure is found to be 25.56 kilopascal. Point A, which is 3.2 meters above point B, has a velocity of flow of 3.5 meters per second and a higher pressure. Determine the velocity of flow at point B. Gamma is equal to 9.81 kilonewton per meter cube. G is equal to 9.81 meters per second. The formula of interest is the Bernoulli's equation, P1 over gamma plus Z1 plus V2 square over 2G equals P2 over gamma plus Z2 plus V2 square over 2G. So if you bring V2 out as the subject of the formula, we have V2 square is equal to 2G bracket P1 minus P2 over gamma plus Z1 minus Z2 plus V1 square over 2G. So we take the square root of the right hand side now. So V2 equals square root of 2G brackets P1 minus P2 over gamma plus Z1 minus Z2 plus V1 square over 2G. V2 equals 2 times square root of 2 times 9.81. V2 equals square root of 2 times 9.81 25.56 brackets 25.56 times 10 raised by 3 divided by 9.81 times 10 raised by 3 plus 3.5 square divided by 2 times 9.81. So that is square root of 126.15, and the answer is 11.23 meters per second. Do not forget to like and share this video. If you haven't subscribed to the channel and hit the notification bell so that you can be notified when we bring another interesting video. So that's the solution to the problem. You can try it at your hand and confirm that you get the same answers that we have provided here. I'm expecting your comments, whatever you get in the problem, the solution. Until another time, say bye bye.